Hi everyone and welcome back. My name is Jazmin Rodriguez and today we will be doing lesson 2 of the semester. As I was working some of these problems, all I could think was how I could not remember how to work some of them. And then I thought of a quote that I was thinking, and that's the best way to learn mathematics is to do mathematics. Sometimes we don't know how to work something, and the best way to learn is to just practice it. And today we are actually on Module 2, and we're going to be talking about sets, whole numbers, number theories, and computations. So get ready for a big learning experience. For our very first problem, we are asked to construct a Venn diagram and to show all 8 elements that they are given us in U. And these are the sets that we are given. We are given that A will have B, C, D, G, and H. B will have D, F, and H, and C will have D, G, and H. So the first thing we're going to do is go ahead and, excuse me for 1 second. We're going to go ahead and build our Venn diagram. And we're going to go ahead and label this part A. This part's going to be B, and then this part is going to be C. And then the next thing we're going to do is we're going to go ahead and put everything that belongs in set A into our set A. And the way that we figure this out is we look at the elements that they're giving us. And you would think that all these elements that they give us are actually going to go into our A. However, the only ones that go into A are the ones that are only common to A. That means that they cannot be in B or C. So in this case, for A, we see that we have B. B is not repeated in B or C. And then we also have letter C. C is not repeated in any of the other sets as well. As you can see, we have D and G and H that are repeated in the other sets. Therefore, A only has B and C in its set. And then for B, we'll go ahead and do the same thing and determine which one of these elements is only found in B and nowhere else. In this case, we see that it's F. And then if we look at C, we see that we don't have anything because the next thing is that we have D, who is found in A, B, and C. So that one is shared amongst all 3 of our sets. And then we also have H, and we see that H is found in A, B, and C. So once again, that's going to go right here in this part of our Venn diagram. And then we see that in elements A and C, we have our element G. So that goes in this part of our Venn diagram. And then once you filled everything in that it's telling us to put in our sets, if you have any remaining elements, they go in our universe. So which one of these elements did not get used? A and D. So now we're ready to go ahead and determine the following sets. So they want us to find B union C for the first one. And in this one, that means that we want to know the elements that are going to be found in B or C. So therefore, we go ahead and list them D. You can list them in alphabetically order. That's what I did. But as you can see, we have D, H, F, and G. Those are the elements that are found in either B or C. The next one is going to be that they want us to find the intersection of A and B. So in this case, this means that our elements have to be in both A and B. And in this case, if we look at it, we have B, C, and G. It's a both, so that's what those 2 elements. And then for our next one, it wants us to determine the intersection of B and C. So once again, we have to determine what elements are in B and C. So as we can see, we have D, H, and G, or D and H, excuse me, because that one's part of A. And then they want to know, the next one is, they want to know the union between A and C. And that's going to be which elements are in A or C. So we have to list all of them. So we have B, C, D, G, and H. Those are the ones that are found in both of these. All right, and then for the next one, as you can see, we have A with an like a dash on top of it, and you would think that this means that they want us to list all the elements that are in in set A. Well, whenever it has the asterisk on the top, it actually means the opposite. It wants to know all the elements except for the ones in A. So we have to list what elements are in everything except for A. And when we do that, we see that we have A, E, and death. Those are the only ones that are not in element A. And then the next one is they want to know the intersection between elements A and C. So which elements are in both A and C. And when we look at it, we have D, G, and H. Those are the only ones that are shared between A and C. And then lastly, we want to know, pardon me, we're right here. We want to know the union between A and the intersection between B and C. And so whenever we do that, we get that we have B, C, D, H, and G. All right. Now for this next problem, we are asked to make a Venn diagram and to use all of the 12 shapes. And we'll go ahead and do a little key that tells us what each one represents. So they give us C, H, and T, and we go ahead and label that C is going to include circular shapes, H is going to be hexagonal shapes, and T is triangular shapes. We also are given S, L, R, and B, which represent small shapes, large shapes, red shapes, and blue shapes. And whenever, once again, we've already kind of went over this, but whenever we see this U upside down, this represents a union, which means it wants us to represent the elements that are included in either or. And then the upside down represents an intersection. And whenever we see that, it wants us to tell them the elements that are in both that they give us. Okay, so for the very first problem that we're given, they want us to demonstrate which shapes are found in the set L intersection H. So once again, the L is going to represent our large shapes, and we'll go ahead and look at our key here that it tells us. And then H is going to be our hexagonal shapes. So here we have the intersection of large hexagonal shapes. And when we do that, we'll go ahead and look at our Venn diagram here. And these are the elements that are in that one. And then for our next one, they want us to show which shapes are found in the set of C union H. Once again, U means union, so it wants to know which shapes are going to be in either circular or hexagonal shapes. So when we do that, we get the union of hexagons or circles. So then we go ahead and go over to our Venn diagram. Let me get a pen so it's easier to see. And then when we do so, oopsie daisy. Let me go back here. There we go. When we do so, these are going to be our shapes that represent the union of hexagons or circles. Okay, and then for our next one, it wants us to demonstrate which shapes are found in the set T intersection R. And once again, we've already kind of went over this, but whenever we see this asterisk on top of our T, it wants to know which elements are not represented in the set. So here, we go ahead and put that T is triangular shapes, so we do not want triangular shapes. And then we have the intersection of R, which represents red shapes. So we want the intersection of red shapes that are not triangular. So then we come over to our diagram here, and we go ahead and determine which ones those are. All right. And then for our next one, we have that it wants us to demonstrate which shapes are in the set of the union or of the intersection C, intersection S, intersection R. So let's go ahead and decipher what each one means. So C would be circular shapes, S is small shapes, and R is red shapes. So here we want to know the intersection of the small red circles. So when we come over to our diagram, we've got to pick those out. And there we go. Okay, for our next problem, they want us to show the Indo-Arabic equivalent of the following Egyptian system. So here we have created a table that demonstrates what each symbol represents in the Egyptian system. And then this is our problem that they give us, and they want us to give the equivalent here. So the very first thing that we're going to do is kind of break down what they give us. And we see that we have 3 pointing fingers. Each represents 10,000. But as we can see, we have 3 of those. Therefore, we'll go ahead and multiply 10,000 times 3, and we get 30,000. Then for our next one, we see that we have 5 yolks. Each yolk represents 10, and we have 5 of those. So we'll go ahead and multiply 10 times 5, which gives us 50. And then lastly, we have a staff. Well, we have 4 of them. And each staff represents 1 unit. And since we have 4, we go ahead and multiply that times 4, and we get 4. And then in order to get the equivalent, we go ahead and add up all of our totals together. And when we do so, we get 30,054. Therefore, the equivalent of the Egyptian system into the Arabic equivalent system is going to be 30,054. Okay, now moving on to the next one, we are given the Roman numeral system, and once again, we need to find the equivalent of the Indo-Arabic system. So once again, we have already created our table that shows us what each symbol represents, and then this is our problem that they give us that they want us to figure out. So first of all, as we can see, we have M, which equals 1,000, and we have C that equals 100. Well, here's where the tricky part comes in, and you have to, and some people mess up on it, so you've got to pay attention. When it comes to the Roman numeral system, it is kind of like a rule that they say that if there is a smaller place digit to the left of a larger digit, then you actually have to subtract the smaller from the larger. When we look at it over here, we have M, which is 1,000, but then we have CM. And as we can see, C represents a lower digit amount than M. Therefore, we have to subtract 100 from 1,000 in order to get the value of CM. So we'll go ahead and do 1,000 minus 100, and we get 900. Therefore, CM represents 900. And sometimes now they've already created a chart where they show you this right here, so you don't even have to do the computation, which is more of the modern one. They call it, I think, the subtractive principle. But a lot of people, back then or even now don't know about it, so you actually have to make sure you compute it yourself. So you just have to remember that rule. And then from here on out, it's pretty easy peasy. We go ahead and look at the rest of our symbols that we are given. And we have M, which is 1,000, CM, which we determined was 900. We have X, which is 10. And as we can see, we have 3 of those. So we go ahead and multiply 10 times 3, which gives us 30. And then we have V, or technically 5. And we only have 1 of those. So that's equal to 5. And then we have 1, and we have 2 of those. So we go ahead and multiply it, and we get 2. And then in order to get our total, we go ahead and add those up. And so we get that the Indo-Arabic equivalent of this Roman numeral system is 1,937. That was fun. All right, moving on to our next one. They are giving us the Babylonian system, and once again, they want us to find its equivalent. And so the first thing that we're going to do is determine how many placeholders we have. And so anytime that there's a space in between, that means that there's multiple placeholders. In this case, we see that they're all together, so therefore there's only 1 placeholder. So now we can go ahead and determine the value of each placeholder, or each digit, excuse me. So right here, we know, I'm going to call these arrows because it's the easiest way. But here we see that we have 4 of these, and we know that each one represents the value of 10. So we'll go ahead and do 10 times 4, and we get 40. And then our next symbol is this right here, and we can see that we have just 1 of those, and it represents 1. So we do 1 times 1 is 4, or 1. And then to get our total, we'll go ahead and add 40 plus 1, and we get that the equivalent is 41. Okay. And then for last one of these bad boys, we are given the Mayan numerals. So this is our chart that represents. And then this is our problem that they give us. And so we need to find the Arabic equivalent. So once again, once they already give you the chart, you just got to, this one you pretty much just look at it and match it. So we'll go ahead and decipher what each one means. So our very first symbol here, we see matches to 5. And then we go ahead and look at our next symbol and find it on our chart. And we can see that that represents 6. And then our next symbol, we'll go ahead and see that means that represents 3. And then for our next one, we see that it represents 17. So once we've already calculated all of them, we'll go ahead and look at our place values. So whenever we're looking at this, our place values, we're going to have 4 of them. So now all that we have to do is multiply our place value by our position holder here. So these go in order. So this one would go with 5, or the first one would go with 7,200. The next one would go with 360. The next one would go with 20, and the last one would go with 1. So all we have to do is multiply the place value by each placeholder. So we do 5 times 7,200, and we get 36,000. The next one would be 6 times 360, which is 2,160. Our next one would be 3 times 20, which is 60. And our last one is 17 times 1, which gives us 17. And then all we're going to do is add up our total values. When we do so, we get 38,227. So this number is going to be our equivalent. All right. Now these right here get really fun. So we are asked to multiply 28 by 32 using lattice multiplication. So in this case, we actually have to make our table. And I went ahead and did that part for you right here. And the way we're going to start is we're going to place the first multiplicand, which is 28, on the top part of our chart here. So we put 28, and then we use our second multiplicand, and we go ahead and write that along the side. Okay, and so now we're ready to go ahead and start multiplying. So the first one is we're going to multiply 2 times 3, which gives us 6. And in this case, since we have just the 6 and the 1s digit, you always place it below the diagonal line. So we'll go ahead and fill in 0. And you might be able to tell that it makes sense to do it that way. Otherwise, if you did 6 on top, you would have to put 0 on the bottom, and that would actually represent 60 instead of 6. So always make sure that you put a 0 on the top. Next, we're going to go ahead and multiply our 2 times, we did 2 times 3. We're going to do 8 times 3, and we get 24. So we go ahead and place our 1s under the diagonal and our 10s above the diagonal. Our next multiplication is going to be 2 times 2, which is 4. Once again, go ahead and place the 4 under the diagonal with the 0 on top. And then we do 8 times 2, which is 16. And we go ahead and fill that in. All right, and now we're going to go ahead and get our total sum. So here we are going to look at diagonals, and we're just going to add them up. So as you can see, our first diagonal is 6. There's nothing else to add to it, so we went ahead and brought that down. And then for the next one, we add 4 plus 4 is 8 plus 1. We get 9. And then we do 6 plus 2, which is 8. And then our last diagonal right here is 2. And so we get that our 28 by 32 is 2,896. And the way you read it is you always read it from the left down to the right. And then we went ahead and plugged it into our calculator just to make sure that we calculated it correct, and we're just that awesome that we did. So we'll move on to our next one. So here we get a little bit bigger, and here we're doing 273 by 628. Once again, we're going to repeat the exact same process that we just did with the previous one, except that we just have more numbers. So the very first thing that we're going to do is put our first multiplicand on the top. So 2, 7, and then 3. And then we're going to go ahead and write our second multiplicand down the side, which is 6, 2, and 8. And you always start with your hundreds value on the furthest left. So that's how it's always going to go in order. All right, now that we have that down, we're ready to go ahead and start multiplying once again. So our first number is 2 times 6, which is 12. So we'll go ahead and place that in our box. And then the next one that we have is 2 times 6. We get 42. And we have 3 times 6, which is 18. And then our next row that we're going to multiply is going to be 2 times 2, which is 4. And then we get 2 times 7, 14. And then we get 2 times 3, which is 6. Once again, always placing the ones on the bottom of the diagonal with a 0 on top. And then we'll go ahead and move on down to our next row. We have 2 times 8, which is 16. We have 7 times 8, which is 56. And we have 3 times 8, which is 24. All right, and now that our lattice multiplication chart is completed, we're going to go ahead and compute the sum. Once again, we start by looking at our first diagonal, which is 4. So we go ahead and just bring that down. And then our next one is 6 plus 2 plus 6. And here we have 14. So what we're going to do here is you place your ones digit down, which is 4, and then you carry your 1 over to your next diagonal. Pretend like you're doing a regular multiplication where you set it from the top to the bottom and you carry your ones. You're doing the exact same thing. And I went ahead and placed it here so that we don't forget it. So then when we move over to our next one, the first thing we do is we're going to go ahead and add our first one. So we do 1 plus 8 plus 0 plus 4 plus 5 plus 6, and we get 24. Once again, you go ahead and put your 4 down. That's in your ones. And we go ahead and carry our 2 to our next diagonal. Once again, we're ready to add. 2 plus 1 plus 2 plus 1 plus 4 plus 1 is 11. Place your 1 down, carry your 1 over. Our next diagonal is 4 plus 1 is 5, plus 2 is 7, plus 0 is 7. So you place that down, and then you go ahead, and then there's 1 plus blank, so you just go ahead and bring that down. And then the way to read our sum is we read it down and across. So our total would be 171,444. Okay. And then for our next one, 964 times 593. Once again, we go ahead and place our first multiplicand on the top, starting with our hundreds first. And then we have our tens and our ones, hundreds, which is 5, nines and tens, and 3 in our ones place. So we go ahead and have that down. Once again, we're going to go ahead and start multiplying. Once again, when you multiply, the best way not to get confused is you're going to always do this, if I can speak today, you're going to go ahead and do this number times all the top ones. So 5 times all of those, 9 times all of those, and 3 times all of the top ones. So starting, we do 9 times 5, which is 45. Then we do 6 times 5, which is 30. And we do 4 times 5, which is 20. We go ahead and move on down to our next row. And we're going to do 9 times 9 is 81. Then we do 6 times 9, which is 54. And we do 4 times 9, which is 36. And then for our last row, we go ahead and do 9 times 3, which is 27. We go ahead and do 6 times 3, which is 18. And our last one is 4 times 3, which is going to give us 12. All right, and then once again, that's completely done. And we're going to go ahead and do our total sum once again. We'll go ahead and carry our 2 down because there's nothing to add to it. And then we'll go ahead and add 6 plus 1 plus 8. which is going to be 15. And once again, we put our 5 down, and we carry our 1 over to our next diagonal. Then we go ahead and do 1 plus 0 plus 3 plus 4 plus 1 plus 7. And whenever we do that, we get 16. We always put our 6 down, carry our 1 on over to the top. We go ahead and add our next diagonal of 1 plus 2 plus 0 plus 5 plus 1 plus 2. We get 11. We put our 1 down, carry our next one up to the top, add the next diagonal, and we get 7. And then in our last diagonal, once again, we don't have anything else to add to it, so we simply bring there's a 4. We have 4 plus 1. See, that's why you have to be careful, because if you forget that 1, then your calculations are wrong. Then you do 4 plus 1, which is 5. So then we go ahead and read our sum from left to right, and we have 571,652 as our total. And once again, if we plug it into our calculator, we'll get the exact same amount. All right, and then this one we've moved up to the thousands place, so we're going to have a little bit bigger lattice chart. So we'll go ahead and start placing our numbers across. So we'll start with our thousands, which is 4, 9, 5, and 2. So 4,952 times 243. All right, and now we are ready to go ahead and start multiplying. Once again, as you can see, we have 3 rows. So in order not to get confused, remember that each row gets multiplied by each one of our column numbers. So 2 will get multiplied by all of these, and then 4 will get multiplied by all of them again, and then 3. So the first one's going to be 4 times 2. We'll insert 8. Then we have 9 times 2, which is 18. Then we have 5 times 2, which is 10. And then we have 2 times 2, which is 4. And then we're ready to move on down to our next row. And we're going to do 4 times 4, which is 16. Go ahead and insert that in. Then we have 9 times 4, which is 36. 5 times 4, which is 20. And 2 times 4, which is 8. And then finally, to our last one, we have 4 times 3, which is 12. Then we have 9 times 3, which is 27. Then we have 5 times 3, which is 15. And we have 2 times 3, which is 6. Okay, and once again, we're done with that. We go ahead and compute our total sum. There's nothing to add to 6, so we go ahead and bring our 6 down. And then we do 8 plus 5, which is 13. Place our 3 down, carry our 1. When we add 1 plus 4 plus 1 plus 7, we get 13 once again. So put our 3 down, bring our 1 up. Go ahead and add 1 plus 2 plus 6 plus 2 plus 2. Once again, we get 13. So place our 3 down, carry our 1 up. 1 plus 1 plus 8 plus 3 plus 6 plus 1 is going to give us a total of 20. So we put our 0 down, carry our 2. Next diagonal is going to be 2 plus 1 plus 8 plus 1 is going to give us 12. So we put our 2 down and bring our 1 over. And then we do 1 plus 0, and that's simply 1. And then once again, we are done here. So our answer would read as 1,203,336. All right. For our next problem, they are asking us to look at what their problem that they have given us, and they want us to round to the leftmost digit to estimate the results of the expression, and then to also make the exact computation. So the first thing we need to understand is that whenever we round to the leftmost digit, we're talking about the number that is furthest to the left. In this case, we are rounding to the nearest 100. So in order to determine how to round it, we look at the number that's next to it. So 8 is our leftmost digit, and to be able to round it, we look at our next number. So if the number next to it is either 5 or greater, so it can be 5 or greater, then you go ahead and round up. And if it's not, then you go ahead and round down to the nearest 100. So that's what that means. So we'll go ahead and do that. And we know that 883 will round to 900 because this middle number is greater than 5. Then we have 465, which rounds up to 500 because the number next to the 4 is 6, which is also greater than 5. And then we have 134, and that rounds to 100. And the reason it does is because the number next to our leftmost digit, which is 1, is a 3, which is less than 5. So in that case, we're rounding down to the nearest 100, so therefore it rounds to 100 instead. So now we can go ahead and estimate the results of the estimate here. And we have that our approximation is going to be 900 plus 500 divided by 100. And when we do that, we get 14. So our approximation is going to be 14. And then to do our exact computation, we go ahead and set it in a different form to make it a little bit easier. And we simply add it. So we do 5 plus 3, which is 8. And then we do 8 plus 6, which is 14. So we put our 4 down, and then we bring our 1. And then we do 8 plus 1 plus 4, which is 13. So we put our 3 down, bring our 1 up. So we get 1,348. And now we can go ahead and divide that by 134. And when we do that, we get an estimate about 10.05. So our estimate is going to be 14, and our exact answer is about 10. So the difference is about four digits there. For our next problem, we are doing the exact same thing, except here, as you can see, we have an expression that has more than one thing going on. So let's go ahead and look first. We'll do 35 plus 7. We'll add our denominator first, which we get 42. Now we'll go ahead and round our number. 254 rounds to 300. As we can see, our leftmost digit is 2, since we're rounding to the nearest 100. The number next to it is 5. And the rule is that if it's 5 or more, you round up. So it rounds up to 300. And then we have 523, and the number next to our leftmost digit is a 2, which is less than 5. So that's going to round down to the nearest 100, which is 500. Okay, and then now that we're ready to find what the estimate is going to be, because we do have more than one thing or more than one operation going on in our expression, we have to decide which one we're going to perform first. So we have this little neat acronym that somebody has already come up for us, and that's called PEMDAS. And the easiest way to remember, or that I learned it in school, was please excuse my dear Aunt Sally. And so it tells you the order of operations when you have more than one going on in an expression. So in this case, we go ahead and start with parentheses. As we can see, we don't have any. So we move on to the next one, which is exponents. And we also don't have any exponents. So we go ahead and move on to the next one, which is multiplication. So as we can see, we are multiplying 5 times 254. In this case, it's going to be 300 because we're doing just an estimate. So we'll go ahead and do our computation first. So we'll do 5 times 300. And then, which is 1,500. And then the next thing, order of operation is addition. So we'll go ahead and add our 500 to it, which is 2,000. And then we finally can go ahead and do our division by our denominator. So when we do 2,000 divided by 40, we get 50. So, I cannot speak today. Our approximation is going to be 50. Now we can compute the exact estimate, or the exact answer. And the way we do that is we do 254 times 5, because we're doing multiplication first based on our order of operations. And whenever we do that, we get that 254 times 5. We do 5 times 4 is 20. So we go ahead and bring our 2. 5 times 5 is 25, 26, 27. And then we do 5 times 2 is 10 times 1. So we get our total answer is 1,270. And now that we have that, we can go ahead and do our division. So we do 1,270 divided by 40, and we get approximately 31.75. So here we have our approximation, and then here we have our exact answer. So we see that we have a difference of about 18 digits there. And then once again, we're doing another rounding. And on this one, we are doing 620 times 430 divided by 293. So we'll go ahead and start by rounding our 620, which rounds down to 600 because our middle digit is less than 5. Then we have 430, which rounds to 400 because 3 is less than 5, so it rounds down to the nearest 100. And then we have 293, and 9 is greater than, or 5 or greater. So we go ahead and round that up to the nearest 100, which is 300. And then we go ahead and do our estimation, and we do 600 times 400, which is 240,000. And then we go ahead and divide that by 300, and we get 800. So this is going to be our estimate. And then we're going to go ahead and do our exact answer. And we go ahead and multiply 620 times 430, and we get 266,600. Once we have that, we go ahead and divide it by our denominator, which is 293, and we get 909.897. So as we can see, this one's is pretty close to. We're only off by about 100 digits here. So that's going to be our approximation, and then this is our exact answer. Okay. And then for the next one here, they're asking us to perform the following arithmetic, which is 432 base 5 plus 133 base 5. And so I went ahead and set it up kind of into a little table so that we are able to keep all our numbers in order, since we're going to be doing quite a few steps here. And then the next thing that we're going to do is we have to know that in base 5, the digits that we're using are 0, 1, 2, 3, and 4. So if we get a number that is greater than 4, then we're going to express that as a group of 5 and then carry the ones over. So here we'll go ahead and look at our very first number. So we're adding. So we do 3 plus 2, which is 5. And then since that's a group of 5, we go ahead and write a 0 down, and we're going to carry our one group of 5 over. And then we do 3 plus 3 plus 1, we get 7. So here we know that we can only have up to 5. So therefore we have 2 more than 5, which is 7. So we go ahead and write our difference down, which is 2. And we carry our group of 5 over to the top. And then we go ahead and add our last one, which is 1 plus 4 plus 1, which is 6. And then there's, there are groups of 5, so we can only write 1 down. And we go ahead and carry our other group of 5. And then there's nothing to add there, so we go ahead and just bring our 1 down. And then we get that our answer is 1,120. So this works out better for me when I'm doing it. It doesn't get as messy, but I also went ahead and did it this way as well if it makes it a little bit easier for you to understand. I've set it up just as a regular addition here. So once again, we did the exact same thing. I just think this gets a little too much for me, but this is exactly the same thing as doing it this way. I just think it's a little bit cleaner. So then we get that 432 base 5 plus 133 base 5 is 1,120 base 5. All right, and then for our next one, we are asked to perform the arithmetic of 628 6 plus 73 6. So in the following one, we were dealing with base 5 digits of 0, 1, 2, 3, 4. And then on this one, we're dealing with base 6. So we're going to be dealing with digits of 0, 1, 2, 3, 4, 5. So as you can see, based on whichever base they give you, the digits are up to that number. So we'll go ahead and do our very first one. I already went ahead and set it up as a table. So we'll go ahead and start with our ones always, and we'll go ahead and start adding. So 8 plus 3 is 11, but we're doing groups of 6 because we're talking about base 6. So the difference is that we're going to write 5 down and bring our 1 over. And then we go ahead and add 7 plus 2 plus 1, which is 10. We know we are doing groups of 6. So if we take one group of 6, we have 4 left over, correct? So you go ahead and write your 4 down, and you carry your one group of 6 up top. And then our next one's going to be add 6 plus 1, which is 7. Once again, you can only have groups of 6. So you go ahead and write the difference, which is 1. And you go ahead and bring over your other set of, or your set of 6. And once you get to this point, there's nothing else to add to it. So you go ahead and bring your 1 down. And that gives us our answer. And once again, I went ahead and did it in a regular form if it makes it a little bit easier for you to look at it. And then you end up with the exact same answer when you calculate it this way as well. And so we get that 628 base 6 plus 73 base 6 is equal to 1,145 base 6. All right, for the next one, we are going to do subtraction. So we are dealing with base 5, we're just subtracting. So we have 414 base 5 minus 43 base 5. Once again, I've already created the chart that works out the best for me. So we'll go ahead and start with our very first. So here we're subtracting. So you do 4 minus 3 is 1. You just go ahead and write your 1 down. And then here, as you can see, you can't subtract 4 from 1 because it's smaller. So that means we're going to go ahead over to our neighbor's house and we're going to borrow 1 from him. So if he has 4 and we're borrowing 1, you've got to take it away from him. So now he doesn't have 4 anymore, he has 3. And then you come on over to our side and that has given us 1 set of 5. So you go ahead and do 5 plus 1, which is 6. And then we go ahead and subtract the 4, which is 2. So you go ahead and do 2, and then we go over to our hundredths place, and we see that we don't have anything else to do. So we go ahead and bring down our 3, and so then that's going to be our answer. And I went ahead once again, set it up this way, and then here I did it a little bit different so that you could see how it looks like. And then at the end, we get that 414.5 minus 43.5 is 1,145. And then once again, for our last operation, we're doing 503.5 minus 24.5. So here we have set up our chart and we are ready to get to it. So our very first thing we're going to do is 3 minus 4. We're in a pickle once again because you can't subtract a larger number from a smaller number without getting a negative number, and we can't do that. So we go ahead and move on to our tens place, and our neighbor doesn't have anything. Okay, so now we've got to go over to the next neighbor's house and see if maybe he has 1 that we can borrow. And he sure does. So what we're going to do is we're going to take 4. We're going to take 1 from our neighbor. So that's going to leave him with 4. So then we have to go in order. We go back to this neighbor's house, and then we have to add or give him 1. So that means he has 10, but now we have to borrow it from him. So now we take 1 away from him, so it leaves him with 9, and we go ahead and bring over our set to us. So then we do 10 plus 3, which is 13, minus 4, which gives us 9, so you bring our 9 down. And then you do 9 minus 2, which is 7, and then there's nothing to subtract from 4, so you bring your 4 down. Once again, I went ahead and did it in this order as well to see whichever one works the best for you. It's the exact same thing. You get the exact same answer. And we get that 503.5 minus 24.5 is going to give us 479 base 5. Well, everyone, I hope that this was very learningful. I know that it was a mouthful, but I hope y'all enjoyed everything. Just remember to always keep trying, keep working on it. If there's something that you don't know how to figure it out, you just, keep working it and you'll get to it. So until next time, I will see y'all then. Thank you.